Hello, everybody. This is Raw Automation Talk. You're here with Johnny Jones from Ingersoll. I'm Brant Wiederholt with Agile Automation. How you doing, Johnny?
Oh man, doing great. How about you, Brant?
Good. So today we're going to be talking about a couple of things. We're going to talk about how to program a plant faster, what a development area looks like, and what kind of features it provides. Successful and unsuccessful projects, digital twin, random number generator, and we'll see if we can get through any of the rest of them. But let's talk. Johnny, how was your week, by the way?
Busy, busy, busy. Machine startups, panel builds. We're staying pretty busy. How about you?
Good. Yeah, same. Doing some website work, some quoting, and then talking to a couple of customers about, pulling some more information out of their PLCs. Even your click and clack, your relay logic machines. So should be fun. So let's we'll go into like how we build a plant faster. You might have seen this on one of my YouTube videos. It was a picture of a helicopter dropping a pallet off. Funny story about this is this idea came from a customer of ours where we wanted to build an automated plants, but to do this at scale, we had to standardize everything as much as possible. Every single plant's going to be unique, little bit different. So you always need the ability to kind of customize it or configure it. But yeah, the main goal was this was his dream. This was unfortunately the same customer that it's too bad it happened, but he became very addicted to drugs, and meth kind of took its course per se. So that's where that ended. It's another funny story that I guess I'll have to share with you later. So along that line, what we try to do is, if we were building a batching plant, you've got, obviously, raw materials coming into storage tanks. You've got a batching system. You've got finished goods coming out to storage tanks, and then that will leave then either through a rail car, a truck, or totes, or whatever the case is. So this system per se, we were going to talk about this, it breaks up into 3 different sections. So you got a bulk transfer system, you've got a recipe engine, and then you've got a storage tank management system. So the bulk transfer obviously handles all the logistics and the tracking of material going from one truck or rail car into the storage tanks. And then you've got the recipe engine to handle all of the logic associated with recipes. And then the storage tank management system is because essentially you've got to keep, especially with plants that have, let's just say 36 storage tanks. And what they want to do is they want to make this versatile enough to where they can start, moving some product, or like, and essentially, like, I guess what would have been an example is that if they want more of a finished good or a raw material storage, they can start swapping some of these tanks that they're not being used or used for something else, and then reconfigure them with the alarms and their specific gravity to where you can get accurate inventory control. So those are 3 products. And again, the main goal for the 3 products is that if we were asked from a customer to build this outright, it would almost take us a year to build. Whereas versus we already have something that's configurable and it's already standardized. And so that way we can actually deploy it a lot quicker and faster by just configuration. We do that. Another feature we're going to utilize is a development area. So with the kind of a development area, you can go through different scenarios. You can do all your testing. A customer can ask you, hey, if you run in this certain way, what happens to it? And then we can also provide some training. So once you have a kind of a fully automated development area that's all simulated, we can actually put this in front of users almost a month ahead of time, so they actually get trained before it. So, and Johnny, I'll let you kind of chime in here, but in my 23 years of experience, this is how projects kind of break up into two different categories. So I won't name names, but this actually includes me too as well, because I've done some failed projects as well. But years and years ago, you would see that if the project came from scratch, you would see a lot of hours building a lot of logic that you should have already had in a standard library. And then what you do is, of course, the project kind of goes up and down, whatever the case is. This is the part where I've witnessed senior programmers get very, very cocky and literally wait until the last minute to finish anything. And then right before commissioning and during commissioning is when they realize that the real scope of the project, and they have to dump tremendous amount of hours fixing all the flaws that they've created. This could be they didn't work with this customer. There was no development area. They didn't do enough testing. This could just be, and this is definitely your guy who spends, and I'm going to throw myself under the bus too, but this is where all of a sudden it's at 10 o'clock on a Friday night, and you've got until Monday to get this plant up and running. And somewhere around 10 p.m. is when the customer's high-level executives start calling you, going, is this ever going to get up and running, blah, blah. And I'm not going to say it was wrong, but another company that I used to work for, when they acknowledge that you've hit the red button, that you're nervous and that you might not make your deadline, what they'll do is they'll actually throw you more labor, more people on the project, which you would think that would be kind of like the best thing ever. Sometimes it works out, sometimes it doesn't. And in my case, I remember one experience where not only do I now have to keep up with all of these executives at their customer site, up to as far as like notify them what's going on and give them status, but I'm also having to update other senior engineers on some of the problems and what they're walking into this project with. So those are some of my experiences. Johnny, do you have any of those?
Oh yeah. Never in a plant scenario. Mostly on a smaller scale. Most of the time it's just because you don't ever get the full scope until you're there on site. And then once you're on site, they're like, well, we told the sales guy we needed this. Well, it never got relayed. Or, it's the one on the left is pretty common.
Yeah. I mean, this, you can make an argument that there was no fat test into this, but, fat testing is one of those things where I saw it's the several $100,000 projects that got those, not the $20,000 or $30,000 or $40,000 projects. Those are designed to be as short and at least expensive as possible. So you kind of get the outcome you get because the cost was reduced so far down that there's essentially no hours into the project, or the project manager doesn't want you on that project anymore. I mean, all kinds of issues related to this, but anyway. On the right-hand side is obviously a smoother transaction. You've already got things that you've already built already in a library. You're just configuring it. And then once it gets out to, and you've tested it, so once you get out to the site, you're doing commissioning, As soon as you do an I/O test, you'll run into a couple of obviously a few bugs, but then you run the logic and it's successful, and then you get to go home early and sleep in your own bed. So those are the differences there. And how I'm going to go into a couple of things that I used to do, and then we're going to go into a couple of the things that we do now. So this is what I used to do as a programmer back in the day, which is just I used to program, and we only had one program, and we would just make those changes on the fly. So when I would talk to anybody who is let's say a C# or any kind of a developer per se, and they would kind of give me the feedback. They're like, so let me get this straight. You're remoting into a plant and you're making changes online to a production area. And I'm going, yeah, that's what I do. They're like, well, don't you make mistakes? And I'm like, oh yeah, we make mistakes. I've dropped product on the floor. I dropped down, numerous issues. So it's not safe. It's all high risk. There's lots of bugs. It's a problem. Now, when you go to some of those customers and you ask them, it's like, I need this plant down so I can test this. And they're like, no. You're not bringing it down. Just do it live because we can't handle the production loss. So then it becomes a struggle of going, well, then it's the customer's issue if of this mentality that there's so many bugs, and then the risk is there. So a lot of times the programmer gets slapped, but it's really because of the customer, not enforcing some type of development area. So anyway, so let's go into this. So you got a total of 4 different options. Now, if you're using Allen Bradley control logics, we'll use this as an example. If you have a 4-slot program or a rack without any I/O, you just have the processor, maybe a safety PLC, and then 2 Ethernet cards. What you can do is you can actually have on the production area the same unit. And what's nice about that is that the same program that's inside your development can fit inside the same production with no alarms. So this program can actually go backwards and forwards, and it doesn't matter. So an example would be is that customer asks us to do a $100,000 project. We write the code and we merge it into the production after we've done a testing to it. Say 6 months goes by, they've done some slight modifications to it, maybe some set point changes to it. We can then go and then say, once they give us another PO to do another project, we actually go on remote in, grab that same project, throw it back into our development, and then develop off this again. So one program is synchronized, I guess, back and forth. So that's the most ideal situation. Option B would be is that the 4-slot is in your development area, but you've got a multi-slot or a 7 or I think it's 16 or 17 slot over on the customer site. So anytime I see this, the only thing you can do is you just have to make the program. You're going to have 2 programs. One's for development, the other one's for production. And then once you finish and test the program over on the development side, you only move the delta, the rungs that have changed. Now, is that ideal? And the answer is no. Will it work? Well, kind of so. It depends. I mean, if this is a critical infrastructure, a critical machine, and a critical plant, then I would say this is not the right path to go. If this is a machine that can be handled some downtime, because essentially you're going to have to run tests on this side a little bit more than you should have compared to this side. So option A is better. Option B is less ideal, but I see this all the time. I mean, LinkedIn is full of a bunch of people that have a lot of control racks that have lots of I/O cards, and you cannot do that, and you cannot move that one single program back and forth if you have I/O cards. It comes with a lot of errors that you have to get rid of, and essentially it doesn't, without a lot of work, it doesn't migrate back to development. Does that make any sense, Johnny?
Yeah, it does.
Anyway, all
You
right.
should just have a 17 rack chassis
Yeah,
for your
yeah. Well,
development.
you called it out. That's option C. So
uh,
you imagine if you're an integrator like us, you know, you can't have 12 customers and 12 different, Allen Bradley racks, and especially with all the IO. It just costs too much. But you can have the same program if you have the same exact IO cards. So that is an option, but it just, it's not financially, ideal. Uh, what makes sense is to swap these racks into a remote rack, and then that way you can go back to having a 4-slot rack as your main PLC rack, and then all racks connected are just remote racks. So then you've got option D, which is, of course, just the programmer going right into the production area. And again, maybe it fits some applications, but the applications that we usually get involved with are something to where the plant never goes down, except with a few exceptions to maybe like 6 times a year for a few hours, and that's it. Then let's go into this. So you've got programmer to production, like we just talked about, which is the worst, which is your commissioning, your startup is going to be awful. You're going to have a bunch of call outs randomly, finding weird bugs. And then every time you do an update, you're also going to have some downtime. And sometimes those downtimes are going to cause, our updates are going to cause a lot of downtime, because again, you're asking a lot from a programmer. This programmer will probably, in general, make 1,000 clicks and a lot of keystrokes in one day. They will make mistakes. And so the only way you can get around that is if you have a development area. That way, everything's been tested. The customer has logged into your system, and they've tested it. You've set the system in front of an operator. You've asked the operator, who's been there for 20 years, can you find any mistakes? And they come back and say, no, I can't find anything. That's when you're going to see your commissioning time, narrow down. That's when your call outs are going to be, a lot more rare. That's when your updates, when you do an update, all you're doing or wanting to do is download the newer program and essentially just program the one change that you made. The rest of the logic stays the same. So your updates are going to be a lot more narrower. So that's the difference, I guess, or those are the options, I guess, as a customer and an integrator that they have. So let's talk about the development and production area real quick. So in our development area, we use the same. We don't use the same PC, but we'll use the same virtual machine. We'll use the same operating system. We'll use the same firmware that's inside the PLC as production. We'll have the same hardware. And, ideally, we want to try to get that nailed down as close to as production as possible. So we are not going to run into these problems where it's just like, hey, there's a bug or there's an error. Oh, this works off of Windows 10 on this version, but not this Windows version 10. So all those kind of small little bugs have already been worked out and weeded out inside of the development area. Another thing I'm going to go into is how we do a development environment. So you've got, obviously you're going to have programmers that are on graphics and a database and programming the logic. And then, they're all going to be, running that inside some simulation logic. They'll test it. They'll check it into the repository. Anytime when we're ready to do a release, we then actually review these changes with the customer. Once they approve everything, then we actually move the files over to the production area. We have to do this because essentially if you do this a couple of times without notifying the customer, then the customer starts getting into a paranoid situation where when they notice any kind of abnormal items changing, they're always giving you a call going, did you just get online and did you just make these changes? And some of these customers are big enough to where they have to let a lot of their operators know about some of the changes that we're about to make. So although agile methodology works out really well, where you get to shove a lot of different changes into an environment as fast as possible, some of these operators you need to notify before these changes happen. So we tried to be as agile as possible. However, we have to scale it back a little bit because obviously the operators need to be trained before you make some of the changes because this is mission critical. Johnny, do you have any questions, or is this like way too much shit?
No, this is even on the machine builds that we do, panel builds, we try to follow something very similar to this.
Okay.
It's not just, hey, here's a box, throw some stuff in it, slap a UL sticker on it, and send it out the door. We try to work with our clients to make sure they're going to get what they expect.
Nice. Few things here. The random number generator. So let's talk about autonomous vehicles real quick. It is really easy to program a car to like follow the the yellow lines or the white lines, whatever the case is. If that was all it would be needed, they would have been done by now. The problem is that it's those last 1% to 2% of the time, whether it's raining or whether it's snowed or whether a kid threw a ball out in front of you. Those are the scenarios that are going to be taking a lot of time. So when we build large, batch processing plants, one of the things we had to do is we had to add a random number generator. We did simulate. We do a lot of simulation, but at some point in time, we were still having some mistakes happen out in commissioning. So what we did is we built a random number generator that puts some, you could call it noise or randomness into a signal to where not every valve operates exactly the same. So we might build a plant that might have 200 or 400 valves per se, but we know in real life that those valves do not close exactly on time. Some of them are closer to the air compressor. Some of them are farther away. Some of them have a little smaller hose, air hose connected to them. So we need to add those types of variables into the production floor to where our inner development area, so we can find those bugs before we actually go out to commissioning. So again, does it solve a lot of problems? No, it only solves like that one small 1% of the time scenarios. But is that 1% willing? Is it worth it? And for our customers, it is. So we add it into our logic. We do test it with it. One of the things we do is we actually throw one bit that switches it over from real devices over into fake and simulated devices. So all of your valves giving discrete inputs and outputs, those are easy. Same with your VFDs. We do flow rates and temperatures, and then tank levels. It gets to the point where operators are convinced that it's real. So one of the projects we did for one of the customers is we set up a new SCADA system screen about 5 feet apart. They had their old system going, but what we did is we said, you find the bugs while you're waiting for a batch to happen, right? They've got about 20 minutes to wait for it to heat up, whatever the case is. Go onto our newer system that you're going to start using here pretty soon. Find out the problems. The only problem is that they got to the point where it looks too real for us. So that's the feedback, which is a good feedback, right? That means we got it right. But this gives them the ability to kind of make sure that all the buttons are working, the layout is working, the way that they want, the colors are work, the navigation is intuitive, that kind of stuff. So those are some of the things we get in that we try to push off to our customers. I think we there's a lot to go over. Let me talk about batching ISA 88 real quick. So, we talked about real quickly, the recipe engine real quick. Let's go into like how that works. So it's broken up into sections, and if you're bored, you can look up ISA 88, but essentially it falls into the engine, which is like a traffic cop, where they're just guiding, what instructions to actually start and which ones to stop. So this is very, very high level. Then you go into instructions like, you can give us an idea of anything you want, right? But an example would be 2001 would mean something. This might mean like a charge. And let me go into that. So 101 charges a project to a target amount. So that is that's an ID, 101. 9004, that's a discharge to a storage tank. So these are IDs related to logic. So yeah, you can see it 3002, that's a heating reactor, 3003, that's the cooling reactor. So when going back here, if you see these instructions, you know that there's logic associated with them. In here, the handler is where the standard logic resides. So anytime I want to add time, that's a time handler. Anytime I want to charge product from one, source tank to a destination tank, that's charging. That logic is exactly the same regardless of whatever tank it is. It goes from there. Temperature, again, you could be heating, you could be cooling, but the logic stays the same. So when customers come to us and want a batching system, most of the time they're paying for these handlers. And then essentially all we have to do is hook up this configuration to the IOs that they've got connected. So let's skip over to the units. So a unit you could almost describe as phases. So, inside of the handler, you've got open valves, you've got a timer, you've got to turn on the motor, you're looking for the target weight to equal the weight. You're going to be turning off the motor, another timer, and then close the valve. So inside of handlers, you'll see phases of logics. And then you've got your devices. So kind of broken up into 5 different categories, but essentially that's what a batching system, IS-8088, entails underneath the hood. For the guys that like the logic or want to see what the program looks like, you can start making a relationship or a link between instructions is the ID code. There's the handler, which is a very universal code. There's the unit, which, let me go back here, that's the steps or the phases that the logic is going to go through. And then you can have the individual devices. So in this case, it's valve number 1. Of course, you're going to have, maybe 50 or 100 or 200 or 400 different valves. And so it'll just be an array of different devices. And you'll have VFDs, motors, and whatever devices you've got. So, sorry, that was a lot. Johnny, did you have any questions about that, or did that make sense?
Oh yeah, it makes sense.
Okay. I think that's about it. Yep, that's all I. That's a lot of talking. I don't know if it's like any other questions you got, or is that?
I mean, what you're talking about, like, I love how you look at it. There's a process to it, and I can go deep on this subject. Is I feel like what you're talking about doing is something that is overlooked. It's I don't have time for that.
I'll agree. This is what we. I mean, I didn't do this 15 years ago. This only happened because customers were requiring it. And then even when they were requiring it to have a development area to test something out, we realized the benefits of it. And, there is additional cost to it. There is.
Oh yeah.
I mean, when you're not only developing logic to fulfill the requirements, but you're also building simulation logic, which comes at a cost. And so, if I were to be able to compete with another integrator who wouldn't do a development area, I'm going to come in expensive. However, the tail end side is I come in with a lot less commissioning time. I come in with a lot less call outs and service calls. So it's hard for a small project to do it this way.
And I go back to what we talk about all the time is how can you take what you just talked about and show, yeah, it's a little bit more, but the way we do things, it's gonna put money to your bottom line.
The only way I can see that happening is that most customers have already dealt with, and I know this is going to be like, I'm going to show this screen to some people and they're going to cry because this is exactly what they deal with right here.
Oh yeah, I mean that's what I do. When I have a customer who wants me to commission a machine or commission a panel that we built, it is that right there on the left. They don't have a scope. I spend my days prying information out of them, and then we get to where it's time to do startup, and they go, "Oh, well, can you have it do this?" Yeah. Well, what about this? Well, we didn't talk about that, and why is this taking you so long? Well,
right.
I could have already had all of this done ahead of time. I mean, we don't do big systems like y'all do, but even little small machines, you can get pretty complicated, or well site automation can get pretty complicated. You know. Anyways,
let me ask this: how many? I still think that HMI design is difficult more than the PLC programming, and the reason is that it's the front, it's the face, it's what the customer sees. Yep. If you write shitty code but it meets the requirements, the customer doesn't know. Correct. Because they're not typically a programmer. However, I've made the mistakes years ago with building whatever screens I wanted, get to the customer site, and then essentially they want to change everything. How do you get to the point where you can show the customer what you're building? I mean, you can provide mock-ups, but I can tell you until they use it, they're not fully on board.
Well, and I always do we're going to get through the startup, and then anything that you don't like, I want you to put it down in writing of what you would like me to change, submit it to me, and then I will make those changes. But let's get through the startup here, and we can make all these changes later on. Because even if they don't like what the screen looks like, the screen functions.
Right. And you can make an argument that, most of my customers are wanting to write a check to us or to you to make it done, to make that problem go away, per se. How much involvement do you want that customer to have? Now, I'll be honest with you, I really actually like customers that actually become employees into my business.
Yes.
That way they know how the sausage is made and they know exactly what they're getting. But that's not always the case. They don't, I can say, 1 out of 10 are that way, versus the other 9 are more of like they're overworked, they're burdened with other activities and other fires to put out. And they don't not have the time to dive deep into the designs of it,
Or they don't care. Just
sure.
That's
Until you show up on site, and when all of a sudden the screen is, it's not behaving the way it wants, or that they need it to.
yeah, the operator doesn't like it, or I don't like the color of it. This button should be over here. I want this logo there. I
Right,
want pictures of this over here.
right.
Okay, great. Put all those down, and well, once we're through with this with commissioning, we'll make those changes after it's all been approved. And
Right.
and then the difficult conversation of, hey, we've asked you, you've had 3 months to get us something, and all I've gotten from you is I just want a basic HMI.
Yep.
So this is a basic HMI. If you want that, now I have to go and undo everything that I've done. I mean, if it's, you know, they don't like the color, I'll change colors. It's not that big of a deal. Um, they want a clock on it, or they want a logo here. Little things, that's no big deal. But I want, when you push this valve, I want this, or when I start this pump, I want this pump to be animated. Or it'd be really nice if you could show flow through the piping as it's going.
No, no.
You know, uh, yeah, we can do that. So
um,
yeah,
yeah, I know that there's a lot of demo models of that. Like, it's shown to the customer about product flowing through the pipes, and but in reality is that I don't think I've ever seen anybody program a product running through a pipe. I've done it myself, but I've changed color of the pipe with depends on what type of product it was or what temperature it was. But yeah, that's the extent of it. And
I,
even some people actually have a problem with that.
I was in
So
a clear SCADA programming class, and it was the application was a pipeline application, and you know they launch pigs through the pipeline to do cleaning. Well, so there's always going to be pig sensors on the line. Most 99% of the time, nobody's monitoring pig sensors on a SCADA system. But in this application, we actually put a pig on the pipeline and had it move down the pipeline as it hit the different.
now was it the pill? I mean, did you
No, it
actually
was a
have?
real pig.
Oh
It
yeah,
was
like a
a
real like
pink pig that
pink.
kind of moved down the pipeline.
Yeah,
I
go
mean, but
for
it
it.
was, we were going through animations with clear SCADA and
Yeah, yeah.
so
Um,
yeah, there was even, we could even trigger a sound too. So every time it hit.
for those that are listening or they don't know what a pigging system is, it's a here. Let me pull it up
Well,
on the web.
even in your realm of food and chemical, they still they do small pigs.
Right. I do like 1 to 3 inch pigs. The reason why they call them a pig is they'll be a little. Let's see.
When you hear them going through the pipe, it sounds like a pig running. That's
Yeah.
what I always thought
Yeah.
is why they call it a pig. Go to a smart pig. That's industry 20 there.
Oh
Yep.
wow. This looks like a medieval torture device.
Yep. Those
Uh,
are doing all kinds of cool data logging.
I'm sure for you guys on the oil and gas, it's looking at because the oil is abrasive, right? So
Yep.
I mean, at some point, these pipes, become brittle or whatever case is, or thin walled. So hopefully, before it leaks, you guys can get a sense of when that thing needs to be swapped out or replaced.
I've never done anything with smart pigging, but I know that they can do all kinds of cool stuff with it.
Yeah.
Pipeline is the safest way to transport any sort of gas or liquid believe it or not,
Yeah.
because of what they do here.
Now these are the smart ones, obviously, that whatever the case is. But this is probably not the dumb pig that you can use to separate two products, right?
Look up a foam pig for pipelining. There you go. There's a crisscross right there. Yep.
Okay, this guy right here.
Yep.
Interesting.
Yeah. So those are the kind of like the big foam pigs. That's what they use when they're getting ready to commission a line. And they'll put foam pigs in front of product. Just so that they can kind of, I don't know. There's some scary things that can happen from what I understand with pigging. Like you never want to commission a line with crude oil unless it's been nitrogen purged or it's got some sort of product in front of it so it doesn't get too hot.
This let me. Ours was for a CIP. This was for a cosmetic company. But essentially, not only does it help out with cleaning the line out, but it also sometimes that product is actually worth quite a bit of money. Mm-hmm. And if you're talking about a 2-inch line that runs, I don't know, 300, 400 feet, you're talking quite a bit of money. If all of a sudden, if you could sell, an 80-ounce bottle for $35, it's a big deal that you could kind of, utilize that product. What's that?
You have product simulated on your piping.
Yeah. This one came with it. Yep. I think you could. Here you go. So there's the pig. You'll see it here. It'll run out of product, and then what will happen is the gate will open up. The pig will be launched from air. Yeah, here you go.
Just think about it. If a sound played and it was a pig squealing.
Yeah, so the pig's gone. It's somewhere in there. But yeah, we should have added the little pink pig going through it. So at some point it'll reappear. All the product from here to here is been removed, and then it will send the pig back using air or water. Goes from there. This one incorporated another CIP system as well. So that's another video, but we don't have to go into it. But yeah, we have to, because it's cosmetic, we have to get it to a certain flow rate. We have to get it to a certain temperature. And depending on the product, we have to run it for a certain amount of time. Cool. We actually talked about pigging along with it. Have you ever done any kind of Wonderware migrations or Iconics migrations or anything like that? Any SCADA?
I mean, I've been through a lot of training on them. Signet, Clear SCADA. I've done some Wonderware training. I've done some Wonderware light systems, but never really done any migrations.
There is so many Wonderware and Iconics systems out there that are, like the one that 6 months ago we came across. It's running on Windows 2000. So, no one supports it. It's got to be migrated. You got to do something with it. But, you either have a choice of either upgrading the Wonderware to another version, or you wipe it out completely because you've got different requirements. So this customer gave us a call because they wanted connection to an SAP system. So Our solution to that was converted over and migrated over to Ignition, and then use SAP's Business Connector to grab, ERP data. Another customer has an old version of Genesis 32. So again, it's old, it's outdated. There's a lot of features that Ignition has nowadays that Iconics didn't have back in the day. So you could start doing migrations, going through that. One of the difficult problems with just upgrading, let's just say Iconics 32 to Iconics Genesis 34 or 64 is that the programming language is completely different. So back in Iconics Genesis 32, it was VB script, and then now it uses, you're laughing because it's old.
No, I've just done a lot of VB script here lately.
So the migration on the screens might be easy because you can turn them from 32 to 64, but you still have to go into every single script and rewrite it. So that might actually take quite a bit of time. And while you're doing that, you may consider even Ignition to be a better option, depending on the features.
What is Ignition's internal programming? Is it all Java?
You can do there's a couple of them, but there's most people choose Python.
Okay.
That seems like everybody in their
pretty easy.
Yeah.
It's forgiving. Let me make it say that. It's more forgiving than VB or C++ or.
Yeah. I mean, I don't program anymore, but what the feedback I would get from it is that everybody and their mom knows how to do Python. Lots of training out there. So big. I wouldn't. I understand why they went that way. Go with somebody that's familiar. Go with somebody that a lot of people know. So anyway, it makes sense.
Yeah, and the syntax of it is that's what little bit of Python programming I've done. That's the syntax has been very easy to deal with, whereas like C++, you're dealing with, you got to make sure everything's in the brackets, and the brackets have to be in the right spot, and Python's a little more forgiving on that.
Yeah. I thought years ago, I thought Python was mostly focused on like vision per se.
No, it's
so
big data, big math. I mean,
yeah. Some of my family members are bigger, a little bit swayed more onto the R&D for like Google and Amazon, that kind of stuff. So they were more working on Python on that kind of stuff. So it's kind of interesting to see a language that can do both per se.